Welcome back to class, everyone. Man, I am so excited for today's explainer because we're going to tackle this massive contradiction you've probably seen in, well, basically every sci-fi movie ever made. Think about your absolute favorite Hollywood space battles, right? You've got lasers blasting, ships exploding with these giant booming sound effects. Well, today we're diving into the actual physics behind those scenes, and spoiler alert, Hollywood has been totally lying to you. We're going to explore the silent symphony of our universe and find out exactly why sound literally cannot travel through space.
All right, so here's our lesson plan for today. We'll kick things off with the Great Space Mystery, break down how sound actually works, head into the vacuum, figure out how astronauts talk, and finally, look into hearing the unheard. Let's get right into it. Starting off with Section 1, the Great Space Mystery. I want you all to just close your eyes for a second and picture a massive rocket launch happening right here on Earth. If you've ever seen a rocket launch, even if it's just on a video with the base turned all the way up, you know it is incredibly intense. The engines roar so loud that the sound waves actually physically hit you. The ground is literally shaking beneath your feet from all those massive vibrations. But take that exact same rocket with those exact same roaring engines and blast it into outer space. The engines are still burning, right? The flames are actually even brighter against the pitch black sky, and that controlled explosion pushing it forward is just as powerful. But if you were floating right next to it, complete and total silence. Zero noise. No roar, no boom. Just nothing. So that brings up a really huge question. Is space actually silent, or are our ears just kind of unable to hear what's happening out there? As scientists today, we can't just accept that it's quiet. We need to figure out the why. This whole explainer is really just our quest to solve this mystery and figure out exactly what happens to sound waves the second we leave our planet. Now, to solve this cosmic mystery, we actually have to jump right back down to Earth for Section 2, how sound actually works. Because honestly, you can't understand why sound goes missing in space until you know what sound fundamentally is. See, sound isn't magic. It doesn't just magically teleport from a source directly into your ear. It's actually a physical chain reaction. Let's walk through it together. Step 1, an object vibrates. Think of it like hitting a drum. Step 2, that vibrating drum skin physically pushes against the air molecules floating right next to it. Step 3, those molecules bump into the next molecules, kind of like a giant invisible line of dominoes falling over. Step 4, this wave of bumping dominoes finally crashes right into your eardrum. And Step 5, your amazing brain translates that vibration into the actual sound you hear. Every single voice, every song you listen to, every heartbeat, it all depends on these tiny, vibrating particles. But check this out. Here's a totally mind-blowing fact for you. Sound doesn't just travel through the air. Since sound is literally just molecules bumping into each other, it can travel through anything that has molecules. In fact, sound travels nearly 4 times faster in water than it does in air. No way, right? But it's true because the molecules in water are packed way closer together, so those dominoes hit each other much faster. So let's think about how sound moves through different materials. We already know it relies on the nitrogen and oxygen molecules floating in Earth's atmosphere. We know it zips incredibly fast through water, but it also travels amazingly well through solid objects like metal and glass. You know those old Western movies where a cowboy puts his ear directly to the train tracks? Because metal molecules are packed super tightly, you can literally hear the vibrations of a train through the solid metal tracks long before the sound ever travels through the air to reach your ears. And that brings us to our very first big vocab word of the explainer, medium. A medium is just a substance, so like air, water, or a solid object that is filled with particles. Sound waves absolutely 100% need a medium in order to travel. Without a medium, the dominoes can't fall because, well, there are no dominoes to begin with. Without a medium, sound simply cannot exist. All right, class, strap in. We've got our terms down, so now it's time to officially leave Earth's atmosphere behind. We are heading into the vacuum for Section 3. So here is the absolute most crucial point. We need to define what outer space actually is. Outer space is a vacuum, and a vacuum is a space entirely devoid of matter. It contains almost no particles or air molecules to carry those vibrations we talked about. Out there, there's no oxygen, there's no nitrogen, there is basically nothing at all. And this right here is the key difference between our loud, noisy Earth and the incredibly strange environment of space. So let's apply what we just learned.
If outer space is almost a perfect vacuum, completely lacking all those essential oxygen and nitrogen molecules, what exactly happens when a massive explosion goes off? I mean, the explosion still produces a blinding flash of light. It still releases just an enormous amount of physical energy. But if you were right there to listen, it would be completely, eerily quiet. Because those sound waves have zero medium to travel through, they don't even get a chance to start. They just disappear. It's an entire universe of violent, massive events happening in total, pin-drop silence. Okay, so we've established space is completely silent, but humans go up into space all the time, right? Let's shift gears a bit to the engineering side of things for Section 4, how astronauts talk. I want you to really think about this for a second. If space is literally totally silent and sound waves physically cannot travel from one person to another, how on Earth, or actually, how in space, do astronauts communicate with each other when they're out there floating around on spacewalks? Well, human ingenuity is pretty amazing. Here is exactly how our astronauts bypass the vacuum of space. Step 1. The astronaut speaks, and that sound travels through the air that's safely trapped inside their own helmet. Step 2. A microphone inside that helmet picks up the voice. Step 3. The microphone converts that sound into radio signals. Now remember, radio waves aren't sound waves. They're actually a type of light wave, and they do not need a medium. So step 4, those radio waves zip through the silent vacuum of space at the literal speed of light. And finally, step 5, a speaker inside the other astronaut's helmet receives that radio signal and turns it right back into sound, pushing the air inside their helmet so their ears can pick it up. They aren't actually hearing voices yelling through space, they are hearing electronic radio transmissions. Now, you might be wondering, okay, but what if they just take the helmet off and yell really, really loud? Well, apart from the obvious fact that there's still no medium for the sound to travel through, here's a pretty dramatic, punchy fact for you. Within mere seconds of taking off a helmet in space, your body would lose oxygen. The complete lack of air pressure out there would be immediately life-threatening. And this really shows us the true core purpose of a spacesuit. Obviously, yes, it prevents that life-threatening lack of air pressure, and it definitely keeps the astronaut from rapidly losing oxygen and passing out. But for the purpose of our lesson today, it does something else that is just totally incredible. The spacesuit literally holds the medium. It creates a safe, pressurized little bubble filled with air right around the astronaut's head. Without the suit, not only would you not survive, but you literally wouldn't even be able to hear yourself speak. The suit provides the essential medium that allows sound to exist in the first place. Let's move right along to our final lesson block today. Section 5, Hearing the Unheard. We're going to take a look at a famous scientific edge case that kind of seems to break all the rules we just went over. I bet some of you are probably raising your hands right now saying, wait a minute, does space make any sounds at all? Because maybe you've been scrolling YouTube and you clicked on one of those super cool, kind of creepy NASA videos titled The Sounds of a Black Hole or The Sound of a Nebula. Are those videos fake? Did NASA just completely get the science wrong here? Not at all. And this brings us to our final vocab word of the day, sonification. Sonification is this totally brilliant process where scientists translate invisible data into audio that our ears can actually understand. See, space isn't perfectly 100% empty everywhere. Some regions have these very, very thin clouds of gas and plasma, and those particles can actually create tiny pressure waves. But scientists aren't using giant space microphones to record them. No, they use advanced scientific instruments to detect the invisible data, and then they literally translate it into a format we can hear. So here is the ultimate reality check when it comes to space audio. The reality is that space itself remains entirely silent to human ears. Even though those super thin clouds of gas contain tiny pressure waves, and even though our scientific instruments can detect those invisible vibrations, the data is artificially transformed into sound through sonification. The universe isn't literally making those spooky sci-fi noises you hear in the videos. Scientists are basically just turning complex data into a really cool kind of audio art so we can experience it. And that, everyone, brings us completely full circle. We started today talking about Hollywood, and now we know the actual scientific truth. Real space is very, very different from the movies. Because outer space is an almost perfect vacuum, completely lacking that medium of packed molecules needed to carry vibrations, it's a vast, beautiful, and almost perfectly silent universe. The supernovas and explosions might be massive, but without a medium, the silent symphony just remains unheard. As we wrap up today's explainer, I want to leave you all with a fun little challenge for your inner scientist. We now know that astronauts use radio waves to bypass the silent vacuum of space. But if you could invent a brand new way to communicate in a total vacuum without using radios, what would it look like? Would you use light flashes? Maybe laser pulses? Keep thinking about it. Keep wondering. And never, ever stop asking questions, class, because every single great discovery starts with just a little bit of curiosity. Thanks so much for learning with me today, and I'll catch you in the next explainer.